Today we're going to look at tidal calculations. So on that you're just going to work out a problem that is on screen. So by now you should know that ports are divided into two. They are secondary ports and standard ports. And standard ports are those that we can find on our ATT, and secondary ones are those that we can find them there because the book would be too big to carry if they were there. So our port and a tag as not if I did prompt it code, obviously not. Um, is a secondary port because we can't find it on our ATT. So if it's a secondary port, you're going to find it and it's going to refer us to a standard port. On our table, this is where we find our port that is on subject to the of which is a secondary port. So it's under a big port or a standard port called Devio. Devio is a standard port, so we're going to use it information to try to solve this problem because our subject port is not a standard port, secondary instead. In the problem on screen, we are required to determine the time and height of all high waters and low waters in the secondary port with the ATT number of 6787 on the date of 16th October 1997. So we're just going to page through our ATT book and find the the standard ports of which we say our standard ports in this case is Davia. So we're going to just go through our book and find it, and we're going to go to the date that we require to solve for, of which is 16 October. So on this day, on a standard part of which is debut with on a specific day 16, we find we find all these we find all this. We find that it has on this time it's at this side and this time it's at this side. To take our problem, we're just going to record all those. I'll just keep it in the bottom corner so that you'll find it for reference. So we're just going to divide our workspace. If we're going to have time and we're going to have height. So it's going to be the time, the tide occurred, and their height. So we're going to divide them into high tide, should I say high waters, and low waters, high waters, low waters. So for the standard part of which is our subject, Devio, of which we find our secondary part that we're talking about, Devio, of which I did spell it right in reference. You can just see here. This is how it's spelled. So you're just going to find the time each side occurred and its height correspondingly. So we're just going to divide our workspace like this. For the height tide on 16 it was 1.8 1.8. The next high was 2 2.0, it all in meters. Then the low was negative. The first low was negative 0.2. The next low was negative 0.4. So now we have the heights. We're going to record the corresponding times for those heights. For a time for which 1.8 occurred was 0.5 0 oh sorry 0.5 0.527 0.527. The next time of which is 2.2.0. It happened on 1739 1739 1739. That is just a bad handwriting. 1739, that is supposed to be 17. Okay, and the next thing we have, we're going to the low waters. For the low water, -2 happened on 1127, and mm, negative 0.4 happened on 2357, which is almost a new day. So first, before we continue with our calculations, we're just going to apply them seasonal change. Seasonal change. So if we apply seasonal change, first time if you apply seasonal change, you need to apply it. You need to apply it, or you should need to apply the inverse of it. So we're just going to go through. Remember, our secondary ports have an ATT number of 6787, of which is about this range here. So we're just going to find our AT, oh sorry, our seasonal change in mean level to be here because it's October and corresponding to an ATT number. So our seasonal change is 0.1 because first time we applied, we applied inverse of it. So we are just going to apply negative 0.2. Oh, sorry, I read that wrong. We're supposed to apply 0.1 referring to our extract because it's the first time we applying it. Seasonal change, we're going to apply it what? Negative. Should we say we applied the opposite way? So checkmate here it what? 0.1. So we're going to apply what? Negative 0.1. So then we're going to apply negative 0.1 from all of our numbers here. So it's going to be, if we apply minus 0.1 here, it's going to be, I don't need to use a calculator for that one. We're going to have 1.7, and here we're going to have 1.9, and here we're going to have 0.3, and here we're going to have 0.5. So we now have applied the seasonal change. The next thing is to interpolate, obviously. So now we've applied the seasonal change, and these are our answers after applying seasonal change. Grouping, and remember on this side we have highs and this side we have lows. So these are our answers after applying seasonal change. We do have difference table that tells for this certain height you're going to use this certain difference. We're just going to find it. So this is our different table, so we're going to use it. It just simply means that if a standard pot have this height, we are going to apply this difference to find a height for a secondary pot. And if it has another height, we're going to apply correspondingly. This one, this one correspond to this one, and this one correspond to this one. Remember, we're looking at the row of our subject ports, of which is our secondary ports. These are highs and these here are lows. Okay, so we're going to start with the height. So I normally interpolate with the calculator, and if you find it challenging on how to do it, you could just use, or you could just get a link, of which I will just link it here, where you'll find on how to interpolate using a calculator. I do have a video on that one. So we're just going to record our data now, of which we're going to say setup, setup stats number 3, it's linear number 2. Then we put our data. We call the one for a standard port our x, and the one for a secondary our y. So our x is what? 1.6. Then our next x is what? 1.0. We're good. So corresponding difference for 1.6 is going to be negative 0.3. Negative 0.3. The next one for 1 is going to be negative 0.1 from here. So I'll bring back my calculator. 0.1 equals sign. Now I have my known difference in height recorded on my calculator on a stat table. Then I want for 1.7, of which is what I'm looking for. It's not on the table, that's why I interpolate. 1.7 is something about here, so that's why I interpolate. In literal English, would have said extrapolate, but you get the sense. Okay, the stats is up there, meaning the data is collected. So we're just looking for 1.7 instead, of which is not on our table. We want to extrapolate to it. Shift stat rec of which is 5, another 5, 5, 5. Then we get a change for 1.7. We now have this answer as our change for 1.7. What do we next? We apply that change on 1.7. So we're just going to write 1.7 plus answer. Should I say I'm applying the change? So I'm going to get an answer of 1.36, 1.36, 1.36. Okay, then I write it down. 1.36. 1.36 is going to be my answer after applying change. Remember, I still have my data recorded for the lows. These are lows. For the highs, these are highs. I remember I started with highs, and these are lows. Sorry that my extract is cut it up like that. So the next thing, you bring back your calculator. You have your data collected. So I'm looking for what now? 1.9. I think this was supposed to be 1.9. Just have a bad handwriting. 1.9. So I'm just saying 1.9 is what I'm looking for. Shifts stats 5, 5. Then I get a change for 1.9 of which is 0, negative 0.4. Then I apply it on 1.9. I add it. I add the answer. I apply the change. I'll be left with 1.5. Then I'm going to record 1.5 here because 1.5 is my answer after applying the change, of which is what I am looking for. So we're good till now. So the next thing we're looking at, we're moving to the lows. These are highs, these are lows. So we didn't collect our data for the lows, so we'll just do it now. So stats number 5, data 2, and then we put in these ones on the y's and this one, I mean this one's on the x and this one's on the y. Okay, so it's going to be 0.5. 0.5 is equals to negative 0.2. Then the corresponding differences for 0.5, you're going to have to apply a change of 0.5, 0.1, I mean 0.1 here. I got it here. And for a change of negative 0, for a height of negative 0.2, we're going to apply 0.4. 0.4. I apply it. Okay, I applied 0.4. I have to apply 0.4, and then I have my data collected. I want for who? I want for 0.3. For 0.3, let me just ask the calculator. So just interpolate for me. 0.3 reg, I mean 1, and then reg of which is 5, 5. Then I get an answer of 1.8. So you need to apply a change of 1.8 if it is 0.3. So I just said 0.3 plus the change. Then I get an answer of 0.48. All these numbers could have rounded off them to 0.5. I will in the end. So the next thing, I do have another one for low of which is 0.5. 0.5. 0.5. I want a change. Was it? Yes, 0.5. My mistake on this one's supposed to be negative because I've been adding. It's supposed to be negative. I think I made a mistake on those. It's supposed to be negative, then I can keep on with my process. Okay, just noted that now. Okay, so I'm just going to drag my extract again in screen. Okay, we're good. So my calculator, we're just going to look for negative 0.3, a change for negative 0.3. We got shifts stats 5, 5. Then I get an answer of 0.44. Then I apply that on negative 0.3 plus my answer. I get this one. Then obviously I made a mistake on this one. I remove it, bring back my calculator, I copy the answer. The answer is supposed to be 0.014. 0.14. I'm so bad with numbers. Then the next thing, The next thing we find a change for this one, then apply it. So this is negative 0, negative 0.5. So we good. Then I want to change 1 and then 5. And then I get my answer 0.5. So it's 0.5. If I round it down, it's going to be 0.5 again. So it's like minusing 0.5 from 0.5. So it's 0.5 should not minus plus the change of which is 0.5. Then I get an answer of which is very close to 0. So that's why I recommend rounding up things to 0 like this. So we now have our tides like this. So the next thing, we're just going to apply a seasonal change. We apply a seasonal change. On the second step, when you apply seasonal change, remember that you apply seasonal change as it is. Please note that we have our seasonal change here for our secondary port to be 0.1. So we're just going to apply 0.1. Checkmate here, 0.1. That's why we're going to apply 0.1. So that off our screen and this off our screen too. Okay, apply 0.1 here. If we apply 0.1, we're adding 0.1, so we're going to have everything increasing. So by 0.1, this is going to be 1.4, this is going to be 1.6, here it's going to be 0.2, here it's going to be 0.1. So remember, we've been focusing on fixing, or should I say adjusting, for the height. Now we need to adjust for the time. We also have an extract on our ATTs that is going to help us adjust for the time. So it's simple, just go and get it and adjust. So this is our extract from the ATT table. So from this we know that um, for high waters we apply, this is, remember, this is our port, so this is what we're looking into for high waters and for low waters. So you're just going to apply that, simple, and then we're just going to learn to the correct times. So these are our times, so we're just going to apply changes on these times. So this is 5. Okay, I'm just going to use just plug on a calculator. So I'll just clear everything on my calculator first. This is my time was 5. For high water, my time was 5 hours 27 minutes. So I'm applying a change of what? Of negative 128. So it's going to be negative 128 minutes. So this is going to be my time. My time is going to be, my new time is going to be, let me use a red pen. My new time is going to be 3. So then, because this one is still on the high, I'm still going to apply the very same change in time. So I'm just going to type in the number of which is 17, the time 17:39. 39, I got it right, 17:39. Then this is going to be our time, 16:11. 16:11. These ones are for the high, remember. Let's do time for lows. Time for lows is we're going to use this one, and the change is going to be this. Okay, bring back the calculator again. 11:27 is our time. Then we apply a change for lows, because on the lows on this one, of which is 0 minus 1 hour and 29 minutes. So we're applying the change in time. We're left with 9:58. 9:58. Remember 0 here, 58. Okay, then remember, it's still the very same change. We're still on the lows, so we're just going to change the time here. Our next time is 23 degrees 57 minutes. Then I land on an answer of 22:28. 22:28. This is our time for high and low waters. And so if you've been following with me, this should be your height, should get answer like this one, your height as I just did down there, and this should be your time. So I hope the video was clear. If you find it Heart, you can comment on which parts you got lost. Thank you.